Hello everyone, my name is Anji Sadhana. I'm assistant professor in CSC AI department at ABES Engineering College. Today we are going to discuss the topic operations and fuzzy relations. And the outline of the topic will be we'll be discussing fuzzy relations first, then we'll be talking about operations on fuzzy relations, then the example of fuzzy relations, and then we'll be discussing about the fuzzy composition and its types, and then we'll be taking the example of fuzzy composition. Now, to understand the fuzzy relation, we firstly basically need to understand the concept of crisp relation. As traditionally, crisp relations were used for performing the different operations, and it basically were used in the hard computing. If we talk about the crisp relations, it can be defined as an ordered pair, such that just a second, such that if we have maybe two crisp relation A and B, the crisp relation will be defined as a Cartesian product of A and B, and which is basically collection of ordered pair of elements of A, set A, and set B, and which will be represented as an ordered pair AB, such that A belongs to A and B belongs to B. In fuzzy also, we basically use a Cartesian product with some different notations. And in crisp, we were talking in terms of the ordered pair, and the value can be 0 or 1 only. If we talk in terms of matrix form, the values of the matrices will be either 0 or 1. If the relation is present, the ordered pair is present, the value will be 1. And if ordered pair is not present, the value will be 0. But in case of fuzzy relation, we find the Cartesian product in such a way that we basically talk in terms of the membership value. We'll be talking about this thing in more detail in the next slides. Fuzzy Cartesian product can be defined in such a way that A be the fuzzy set on universe X and B be the fuzzy set on universe Y. Then the Cartesian product between fuzzy set A and B will give a fuzzy relation R such that R belongs to X cross Y. R is a subset of X cross Y. Where the relation R is a membership function, and it can be represented this way. Mu R is representing the membership value. Membership value can be, membership function can be represented as mu, and this mu A cross B is representing the membership value on the relation belonging to A and B, and we'll be taking the minimum value of A and B sets for finding the Cartesian product of the relation. If I take the example here, say if we have two fuzzy sets, set A and the set B, and we have three elements in set A naming A1, A2, A3, and two elements in set B naming B1 and B2 with their respective membership value. Ordered pair here means, in the fuzzy set means, the element and the respective membership value. Say for A1 element, we have membership value 0.2. For A2 element, we have membership value 0.7. For A3 it is 0.4. And similarly, for B fuzzy set, we have different elements, say B1 and B2, with their respective membership value as 0.5 and 0.6. And while finding the relation over A cross B, two fuzzy sets A and B, this can be represented this way, A cross B, and we'll be taking the minimum membership value on the respective location. So these are the elements. A1, A2, A3. This is B1, B2. Here, at this position, we have two possibilities, A1 and B2. We'll be looking at the membership value of A1, which is 0.2 here. And for B1, the membership value is 0.5. And out of these two, 0.2 is the minimum value. using this formula, I'll be writing 0.2 here. Using this formula I'm using here. And at this position, for B2, we have A1 at level X and B2 at Y. So I'll be looking at the membership value of A and B. A is 0.2 here and B2 is 0.6. Again, the minimum membership value will be chosen, which is 0.2 here. Now at the next point, A2 and B1. For A2, the membership value is 0.7, and for B2, just a second, for A2 it is 0.7 and for B1 it is 0.5. I will be taking the minimum value, which is 0.5 here. Just 0.5 here. And similarly, we can calculate the respective locations, membership value for the respective locations. The minimum value will be chosen. Say for A2 and B2, the minimum value is 0.7. It will be compared with A2 and B2. It is 0.7 and 0.6. And the 0.6 is the minimum value. So that's why 0.6 has been chosen here. So this would be the year. This would be your final matrix. Coming to the next slide. This way we can calculate the Cartesian product of the two different matrices. Cartesian product basically represents the relationship matrix here. As we have seen in CRISP set, the relationship matrix is represented using 0 and 1. And in the fuzzy set, the relationship matrix will be in terms of the membership value. And we have chosen the minimum membership value to represent the relationship. Then the different operations that are present or that can be performed in fuzzy relations or CRISP relations as well. We have different operations such as union, intersection, and complement. The union will be represented as the maximum value of the membership value, and for intersection of the two relations, we'll be taking the minimum value of the respective membership values, and for the complement, I'll be taking the 1 minus the membership value. If we are having two fuzzy relation R and S on the Cartesian space X cross Y, then the operation can be applied in this way, and the representation would be this way. So if I take the example here, so these are the two relations R and S, and if I want to perform the union operations here, say R union B, R union S, the same matrix. The one thing to note here is that the matrix size should be same if we are using performing the union operation. Here we can see the matrix size for both R and S is 3 by 3 matrix, and we have the elements here 3 by 4 matrix, sorry, and we have the elements here. And if I try to perform the union operation, the respective location would be considered and the maximum membership value at the respective locations will be taken as an outcome. So here, x1, y1 location, we have 0.8, and in S matrix and in S relation at x1, y1 position, we have 0.4. The maximum value is 0.8. 0.8 will be chosen. Similarly, we can calculate the other values. We can compare and find out the result at the other locations. It will be 0.9. And if I compare 0.7 and 0.6, the outcome will be 0.7. 0.0 and 0.9, the outcome will be 0.9. Then it will be 0.8. And it will be 0.5 here, 0.7 here. I'm just taking the maximum membership value as an outcome of the union operation. It will be 0.9, 1, 0.8, and 0.8. I just need to compare these values. For this location, I have compared value this and this value, and the maximum value is written as an outcome. So this will be the outcome for the union operation. And if I compare the values for the intersection operation, we'll be taking the minimum value here. As we have discussed 3 types of operation: union, intersection, and the complement. For performing the intersection operation, we'll be taking the minimum values here. This is the matrix that we want to calculate, we want to form, and the respective location values will be compared here. Say if I compare the value at location 1, x1, y1, The values are 0.8 and 0.4. That's why we need to take the minimum value, which will be 0.4 here. The next minimum value at this location will be compared. 0.1 and 0.0 will be compared. The values will be 0. The next value will be 0.1. The next will be 0.6. Then 0, 0.4, 0, 0, 0.3, 0, 0.7, and 0.5. These would be the minimum value. So the intersection operation would be resultant of the respective minimum values. And if I take the one complement, if I take the complement of the particular relation, say if I want to complement the value of relation R, it will be, I will be subtracting the values 1 minus 0.8, 1 minus 0.1, 1 minus 0.1, 1 minus 0.7, and so on, and the resultant would be, let's see, so it will be 0.2, 0.9, 0.9, 0.3, 1, 0.2, 1, 1, 0.1, 0, 0.3, 0.2. This will be the outcome for the complement operation here. So these are the outcomes that we have calculated. I have shown you the step-by-step implementation of these outcomes. Now the next topic is the composition of fuzzy relation. They are basically used to represent the relationship between the elements presenting in the relation R and the element presenting in the elements that are present in relation S. Suppose R is a fuzzy relation on A cross B and S is a fuzzy relation on B cross C. Then we want to find the relationship between A and C elements. Then it could be represented using the composition relation. There are two types of operations that can be performed for performing the composition of the fuzzy relation. First one is the maximum composition, and the next one is max product composition. We'll be talking about them one by one. Suppose R is a fuzzy relation on A cross B, and S is the fuzzy relation on B cross C, and the P would be the fuzzy relation on X cross Z. As I just told you, it basically tells the relationship between the elements on the different elements that are present in different relations. So this can be represented as this. If I take the values here, mu is R can be represented as this value, maximum of minimum of the elements that are present here. We'll be taking the XY elements and the YZ element, and the relationship between X and Z will be computed, and the resultant will be provided. Next, if I take the example for performing the composition here, say we have two elements, we have two relations R and S. R and S. We are given that the R is a relationship between X and Y. X has the elements X1 and X2 represented here, and Y is the fuzzy set having elements Y1 and Y2 represented here. Z is represented as this, and S is the relationship between two fuzzy sets Y and Z. So these are the elements of Y and these are the elements of Z. And if you want to compute the relationship between the elements of fuzzy set X and elements of fuzzy set Z, then I'll be using the composition here. So it will be R composition S. So to perform the composition, the resultant matrix will be, this size is 2 cross 2 and the size here is 2 cross 3, and the resultant matrix size will be 2 cross 3. The elements will be X1, X2 here, and Z1, Z2, and Z3 here. Now, for finding the composition, I'll be using the formula max min of xy and yz as we discussed in the previous slide. So here, I'll be taking the example. I'll be taking the actual values here. So for at this value, we want to reach from x1 to z1 using the y1 values here. So I can write it as max minimum of x1 y1 y1 z1 then minimum of x1. How can I reach from x1 to z1? We can reach using two values x1 y1 and y2. I'll be writing here x1 y2 and y2 z. I'll be doing the operations. I'll be doing the computations here. We're writing minimum of x1 y1 from here, from the relation R, we can see the value of x1 y1 is 0.7. So I'll be writing 0.7 here. 0.7 and the y1 z1 here is 0.8. I'll be writing 0.8 here. Then I'll be taking the minimum of x1 y2, which is 0.6, and y2 z1, which is 0.1. The minimum of these two values, 0.7 and 0.8, is 0.7, and the minimum of 0.6 and 0.1 is 0.1. And out of these two, I'll be taking the maximum value, which is 0.7. So at this position, the value will be 0.7. And to calculate the next positional values, I'll be using the same method. Just a second. So here also, we want this value from x1 to z1, z2. Find the membership value of this relation. I'll be writing maximum of minimum of so value from x1 to y1, x1, sorry, y1 to z2. The same way that we have computed the previous value, x1, y2, y2, z2. Now if I compare the value, it will be maximum of minimum of from x1 to y1, we have values 0.7. From y1 to z2, this value will be 0.5. I'll be writing here 0.5. Then I'll be taking the minimum of next combination x1 to y2. It is 0.6. And from y2 to z2, it is 0.6. The calculations will be done this way. Minimum of these two value will be 0.7. The next value, minimum value will be 0.6. And the maximum value will be 0.7. So outcome will be 0.7 here. Similarly, for calculating the Z3 value, we'll be going from x1 to Z3 here. This will become Z3. I'll be writing the competition, direct competitions here, and I hope you just understood the concept. So here at this location, we are going from x1 to z3. I'll be writing z3 here. Writing z3 here. It will be maximum of minimum of values from x1 y1, which is 0.7, and y1 z3, which is 0.4, minimum of x1 y2, which is 0.6, and y2 z3, which is 0.7. Outcome will be maximum of 0.7 and 0.7 will be 0.7 here. So here also we'll be getting 0.7 as the outcome. And for the next row, we want to go from x2 to z1. Now this value would change. Let me erase the value here. Now this value would change as x2, and we want to go from x2 to z1. We want to find this location value. So this can be done using y1 and y2. It will be maximum of minimum of value from x2 to y1, which is 0.8 here. x2 to y1 is 0.8. You can see here. Then y1 to z1 is 0.8. Minimum of. Then again x2 to y2 is 0.3. And y2 to z1 is 0.1. The maximum value will be 0.8. So here 0.8 will be written here. Similarly, you can calculate these values as well. Here it will be from x2 to z2. x2 to z2. Again, the operation can be performed as this way. It will be maximum of minimum of x2 to y1, that is 0.8. y1 to z2, it is 0.5. Minimum of the next would be your x2 to y2, which is 0.3, and x2 to y2 to z2, which is 0.6. Outcome will be 0.5, 0.3, it will be 0.5. So here it will be 0.5. Similarly, for next value calculation, we need to calculate the value here as from x2 to z3. And the value will be calculated in such a way that maximum of minimum of from x2 to y1, that is 0.8, and y1 to z3, it is 0.4. Then minimum of x1 to x2 to y2, it is 0.3, and from y2 to z3, it is 0.7. Minimum value will be chosen, and then out of these two minimum value, maximum value will be chosen. And this will be the relation which basically shows the relationship between element of set fuzzy set X and elements of fuzzy set Z using the fuzzy set Y. We have used here maximum product min-max method. Similarly, we can go and for calculating the max product method. In the max product method, rather than finding the minimum of these two values, we'll be computing the product of these two values, and the same thing will be done. These computations we have done, and this was our resulting matrix. And for this example is for practice. You can practice this at home, and you can find out. We have given with the two sets, set P and set B, which basically represents the set P represents the paddy plants, and the set B represents the disease here. And in addition to these, we can use this S set, which basically represents the symptom. Using this disease matrix, disease information, we need to find out the relationship between the paddy plant and the symptoms that are present to basically for having this particular type of disease. That R be the relationship on P cross D, which represents the plant is susceptible to which disease, and R can be stated as this way. And T basically represents the relationship between the disease and its symptoms. And using these two information, we need to calculate the relationship between the paddy plants and the symptoms using min-max computation. And these are the references that I have used for making these slides. These are the two books that can be used. Thank you.